Rank the number of subatomic particles with this Y isotope, with a 69 in the top left and a +4 in the top right. To make sure we're clear, P represents the number of protons in our isotope, E, the number of electrons, and N, the neutrons. And with that, we have 3 pieces of information to go off of. But we definitely want to figure out Y first. Why? Well, I'll tell you why. Y is the element of yttrium on the periodic table, with 2 different numbers in its box, 39 and 88.91. 39 is the atomic number, and it helps us find out P, E, and N. That's because atomic number is synonymous with proton number. So since, for example, iron has an atomic number of 26, each atom of iron would have 26 protons. So since 39 is the atomic number of yttrium, our isotope of interest must have 39 protons. We could also write 39 in the bottom left corner of the isotope. In fact, the top left number, 69, is the mass number, and the top right, +4, is the net charge. Let's dissect our mass number of 69, and we very well could at this point also dissect net charge. Mass number, also denoted as A, is the sum of all the atom's protons and neutrons. For atom of interest, mass number is 69. Since mass number is a 3-variable equation, we can rearrange this equation to solve for any one of the 3 variables given the other 2. And since we know mass number and P, but not N, let's rearrange to solve for. We plug in the values we know for mass number and proton number, and we get that there are 30 neutrons. The isotopic notation we have also sets us up to do this calculation top to bottom. 69 minus 39 gives us 30 neutrons. Regardless, we know that there are more protons than neutrons, so answer choice A cannot be correct because it contradicts this fact. The only other component to dissect is our +4 net charge. Each of our subatomic particles are distinguished by their charge. Protons are +1, electrons are -1, and neutrons are neutral. Consequently, because these particles compose atoms, they contribute to the charge overall of the atom, called the net charge. In fact, net charge is simply the sum of protons minus electrons in an atom. Neutrons are not included because they have no charge to contribute. Since net charge equals P minus E and we have 2 of the 3 values, there must be 35 electrons total for this atom. Therefore, the correct answer is B. N is less than E, which is less than P. To ensure you understand how to write and read full isotopic notation, be sure to check out the video on your screen and in the description.